Hey, what's up YouTube? This is the second tutorial about linked lists. Now, in the first tutorial we used a while loop to traverse the list. Now, in this one I want to introduce you guys to a topic called recursion. And just don't even worry about typing anything right now. I want to just explain what recursion is very briefly. Recursion is when a function or a class, in this case it will be a function, when a function calls itself. That sounds crazy, right? But it's very useful, and I'm going to show you how to do it in code. There's a lot of tutorials out there on how to do it with, factorials. I don't really, do that, so yeah, this is just how to do it with like holding things. Like in this case, we're going to be holding a name, but we could just easily be holding like a phone number, a name, whatever. Instead of this being a class list, this could be a class. Or this could be a class person or whatever. So yeah, so we're just going to hold name, and I've added, it's all the same, everything's the same except I've added two new functions, this rec add, which is recursion add, and this rec show, recursion show. So let's just go through and do the rec add. So I kind of added, this is the add name function, which looks obviously a lot different than the add name function we built in the last one. So I just made a string temporary name, and see, I'll enter name and see in the temp name. Now the first thing is going to look pretty similar to the one that you did before, which is that if root is null, we want to assign it the value of temp name. So if it is null, we want to assign it the value of temp name. And this is how we do this. We say root node equals list. Now we didn't have to do this last time, but this time we have to actually make it a new list for this to work. Otherwise we'd be assigning this name value to something that is null, and that would not work. So equals temp name. Okay. Else, what we're going to be doing is this. We're going to call the rec add function, and we're going to pass in root node, and we're going to pass in temp name. Okay, so if it's null, if this is the first name in the list, then we're just going to make root node a new list, a new item, and we're going to assign it the value of temp name. Otherwise, if there's already something in the list, we're going to call this rec add function. So let's go ahead and call rec add right here. Sorry, I'm using Visual Studio 2012 beta, and if you zoom in like I am so you guys can see the code more clearly, you lose your placeholders here with the this collapsing thing. I don't like it. Hopefully they'll fix that before they actually release it. Anyways, but yeah, that's another story for another time. So what we're going to say here, when we pop into this rec add, we're going to say if new list next node is not equal to null, then we're going to call the function again, and we're going to pass in the next node's value and temp name. Okay, and I'll explain that a little more in a second here. Else, excuse me, new list next node equals new list. Okay, and next node name equals temp name. Okay, so let me explain what this does for a second here. Basically what this does is we're going to pass in the root node, the starting point, and we have to pass in the starting point so that we know where to begin from. And we're just basically saying, hey, so the first one will be root node, or the head of the list. It's actually called the head. I call it the root. You can call it the root or the head. The root is really more for binary search trees, which will be my next tutorial. You could call it root head node or whatever, but I just call it root node, whatever. So we're saying we'll start off with the root or the head of the list, and we're basically saying while it's pointing at something, while its next node is not null, we're going to call this function again, and we're going to pass in the value. We're going to pass in the item that root node is pointing at, or the item that this new list is pointing at. So let's say we have a list that has 3 names: Bob, Bill, and Sally. So it's going to start with Bob, the head, and then it's going to go pass in Bob, whatever Bob's pointing at. And it's going to say, well, Sally is not pointing, but Sally is pointing, so it's going to call back, and it's going to keep going until we get to the end of the list. Once we get to the end of the list, then we create a new list. Remember, new list, next node, new list, and new list, next node name equals temp name. Okay, pretty simple. Not really super complicated. It's yeah, not very super complicated at all. So let's go to this rec add here. Sorry, that's a destructor. Let's go to a show name function. So basically what we're going to do here is what I should have done in the first one. I forgot, but you should really have this too. So I didn't add that last time, and you really should. That way it doesn't error out on you if root is null. So if this is null, then actually I don't need that or that. Then I'm going to call the recShow function, and I'm going to pass in the root node. Once again, we have to pass in the root node because we need to know where to start from. So there we have it. So let's go into the root node. Or excuse me, the recShow function, and let's prototype this out. So we're going to see out. First thing we're going to do is we're going to see out the name, and that's going to be new list name. Okay, now we're going to say if new list next node is not equal to null, then we're going to call the recShow function, and we're going to pass in new list next node. So in this way, we're going to basically start with head, and we're going to see out the name, and then if it's pointing at something, if there's more items in the list, it's going to call the next item in the list, and it's going to pass in the name, and it's going to keep calling this function until the list is empty. And this is really the essence of a recursive function. It's a function that calls itself until its job is completed. Not really difficult, but it does seem to give a lot of people a hard time. But recursive functions are pretty important, and they're pretty useful. Now you could just as easily use a while loop, but recursive functions, when you get especially more complicated programs, probably won't cut it. Or they may cut it, whatever, but this is the more correct way to do this, and it's with recursive functions. Also, like I said, there's plenty of tutorials on YouTube about factorials and stuff like that that, you know, are very useful. Recursive functions are very useful. So let's go ahead and see if I missed anything. I hope I didn't. And it builds, and let's see if it runs, and if it runs well. We're going to enter a name, and we're going to enter Bob, and we're going to enter in Timmy, and we're going to enter in Sally, and we're going to enter in Bobbert. And let's go ahead and see the names, and Bob, Timmy, Sally, Bobbert. So that's it. It all works, and yeah, it's pretty simple. And this is just a really brief introduction to what recursive functions are. They're not that difficult, but they can be kind of confusing. Now, what I didn't do is I didn't go through here and change list, the destructor. Now, I'm still using this destructor that I created as a while loop, and it looks exactly the same way as it did in the first video. Now, if you want to change this to be a recursive destructor, there's something that you should know. you cannot pass a variable to a destructor. Like let's say you wanted to pass in a string name, right? And let's say you go ahead and you go down here and you say, oh, let's pass in a string name. Okay, let's see. I'm getting this error, and what does it say? It basically says destructor may not have parameters. And basically what that means is you cannot pass a destructor parameters. So it will not run, it will not compile. So what you'd have to do is create the destructor right here, and then make like a private void, rec destruct or whatever you want to call it, and it can do basically the same things that that this does, and it's actually easier than this while loop. This destructor is kind of funky if you look at it. It's easier to do it with recursive, with a recursive function. Also, it's good to have your recursive functions, at least this one, private, because then you can have your void name public, and it's better to have this. If it can be private, it should be private. So although we could make everything public in here for this program, just a good habit to get into is to make things private that can be private. So there you have it. There's my tutorial about recursive functions, and make sure you stay tuned and for my next tutorial about binary search trees. And you're really going to have to understand recursive functions to understand binary search trees. And binary search trees are better than lists in a lot of cases. Not every case, but in a lot of cases it's a lot better. So I hope you enjoyed my tutorial, and oh yeah, let me open up main just in case you want to copy along with what I did. So go ahead and copy along, and yeah, I hope you enjoyed the tutorial. Thanks a lot, YouTube.